Let me get you how to solve another question under what now? Under electrical energy and what and power. Now we have a question that is a 3 kilowatts electric wire is designed to operate from 240-volt supply. We have to calculate the resistance of what of the wire. We have solution in this case now. So where we have a 3 kilowatts. 3 kilowatt means what? It means what? Electrical what? Power, right? So you have the power as 3 kilowatts designed to operate from 240. We have the volt, like 240 volt, we have 240 volts. We have to calculate the resistance. So we have the resistance as unknown, right? Now in this case, now we need to convert this one from kilowatts to what? To watts. Because power is what is always in watts, not in kilowatts. So we're going to say that to convert it now is going to be 3 times kilo is what is 1,000. That is 1,000. That will give us what? Actually give us 3,000 watts. That's our power. Now to calculate for what now? For the resistance. Since we are giving power, so always remember that formula for power, electrical power is what? Is current and what? And volt. That is what the general formula for it, okay? Now when you get electrical power as current and volt, and in the question, current is what? Is not involved, but we have voltage, right? And we have to what? To calculate for the resistance. So what I have to do is what now? When you have solving question under any topic that's under electrical energy and power, you must know their what? Their general formula. For power is for this. For power is what? Current and resistance. But for electrical energy, someone is always what? Current, volt, and time. Right? Now the first thing that comes to mind is what? Is the Ohm's law, okay? Which is volt equals to current and what? And resistance. Now in this case, now we don't need current, and we need to find resistance. What means that we need to introduce resistance to what we have in this formula here. Which means that we are going to what? Make the current the subject. So we have to remove the what? Make current the subject. So we have to equate the resistance first so that the current can stand on its own. We now have current equals to volt over resistance. Now when you have the current at volt over resistance now, then we what? You replace current with what? Volt over resistance. Okay, so come out to this formula that we have here. So we are going to have power equals to what's our current now? Volt over resistance. Then times what? Times the volt that we have here, which will give us what? Which will give us V square over what? Over R. V times V give us V square, right? So the electrical power is what? Is V square what? Over R. Now once we've done it now, then we are able to what? To solve the question. So let's go. So we have electrical power is given as what? That is 3,000. That's at 3,000. Then equals to what is our voltage? Voltage is given as what? 240. So we have 240. Don't forget we have squared here. Then over the distance is unknown. That's what you have to calculate, right? So let's start to solve it now. So 240 squared will give us what? Let's check it out. So we have 240 times 240. What that simply means? 240 times 240. That is 240 times what? 240. That should give us 57,600. So we have 3,000 equals 57,600 over resistance. Now when you cross multiply in this case now, so we have this multiply this one is here. We have 3,000 R equals to what? 57,600. So you have to equate this 3,000 so that the arrow can stand on its own. 3,000. So this equate what you have here. So we have resistance as what? Let's try to divide it now. So we have divided by 3,000. Now give us 19.2. We have 19.2. Approximately we have 19 ohms. So don't forget to watch. I hope you find this class very interesting, right? So don't forget to like the video, share, and comment. See my last video. Thank you.